Good afternoon. This is a recording before the midterm covering Lab 7 Part 1 related preparation, and we are going to review some general concepts and also some questions from the recent exams. You have all the links to various items. So let us review the Lab 7 Part 1, the 3-element adder. So X, Y, Z, the 3 elements are read from the register file, which is internally forwarding register file, and conveyed to the next stage, EX1, then further EX2, where A and B, X and Y are added first, and to that sum, the Z is added, and the final sum is written. The write back result data, RD for result data, is written to the register file. At the location, the result address is carried through the pipe and then conveyed as result address. And there's only one instruction: add those 3 items or no op. So here single bit opcode run is the opcode. So if run is true, it's not a no op, and that goes further, and the WB write will go like that. And these are for converting bubble or injecting bubble. So if stall is true, stall bar is produced using an inverter, and that stall bar can inject a bubble. So even if this is a valid instruction with run equal to 1, with a 0 here, a 0 goes here, that means a bubble gets injected. Similarly, if there's a overflow here, the run gets cancelled or it turns into a bubble as it goes here, and same thing here. I need to put an inverter. If cout is true, then I want to nullify that instruction, and that becomes the WB write. So what are the occasions for stalling? First, there is a comparison station with all the external comparison units which do not include the internally forwarding register file comparison units. The internally forwarding register file, while the WB instruction is writing, if somebody is reading, the internally forwarding arrangement will try to convey the latest by comparing the 3 sources with the single destination and confirming that he is writing. And so there are 3 comparison units inside. Besides them, we need some more comparison units here to say, well, this junior, if he is dependent on this senior number 3, that is taken care of by internally forwarding register file. But what if he is dependent on senior 1, senior 2? So these will be 3 comparisons and these will be 3 comparisons. So 3 plus 3 is 6 comparison units are in the comparison station. And our naming convention says, if I compare IDXA with, for example, EX1 RA, EX1 result address, IDX source address. If the comparison matches, we say the comparison is done in ID stage, and the comparison is between X, meaning X address, and that match with always is the result address, but where is the result address? EX1. So IDX matches with EX1 is the name of this, and our convention, naming convention is this ID matches with EX1, which says IDX address matches with EX1 result address. That comparison unit is in the comp station in ID stage, and this prefix ID says where it is produced, and that is taken through stage register into the next stage. So the yellow part or highlighted yellow part, namely X matches with EX1, does not change as that signal is taken through the pipe, but the prefix changes as you walk. So please know this convention. And here we are pictorial, so we understand that there are 6 comparison units for the junior to compare with senior 1 RA and senior 2 RA. The 3 source registers compared with EX1 RA. For example, this RA, this is EX1 RA and EX2 RA here. Okay. Now, the Z is less demanding because he can wait until EX2, and by that time all seniors would have produced their values and would have left. So since he can collect the help as late as EX2, we never have to stall because he is not demanding, he is not requiring help early. So why there are 2 muxes? Well, if Z is here, a junior with Z, depending on this senior 2, if that is the case, even if you say, I don't need help right now, I'm not interested in receiving help, I will collect the help in the next clock, then senior 2 will say, by the time I would have gone, take it or leave it. Okay, I'll take it. So that's the kind of situation for Z to collect help. So it's a little confusing, but we need to understand that this line means I, the junior, for my Z, I'm collecting from my senior 1. But if the line is drawn like this, I, the junior, I'm dependent on my senior 2 and collecting his help. So this is junior senior 2 situation, and this is junior senior 1 situation. The only situation that cannot be cannot be helped through forwarding is for X or Y who needs help at the beginning of EX1 clock. This guy can help, senior 2 can help at the beginning of the clock, but senior 1 is still working on producing his result. So dependence between these two or these two, as indicated by this, we have to stall. We cannot handle the dependency. A little confusing is this is what you need in this. If I appear to be dependent on him, as indicated by this, and that after one clock looks like this, after another clock looks like this, so this value ID Z MX1, ID Z matches with EX1 RA, that information should be brought here and should participate in Z forward 2. So quickly let us try to produce the Z forward 2, Z4W2. So I take this through EX1 to EX2, so I'm going to change this to EX2, and I want to confirm that the donor or the senior is a qualified senior, so WB right. So if these two are true, then I can forward to him. What about me? What if I'm a no-op? If you are a if recipient is a no-op, it doesn't matter. He doesn't care whether he receives forwarding help or not. For stalling, you want to check whether the instruction being stalled is not a no-op. Because stalling a no-op is wasteful, but forwarding unnecessarily to know of is no harm, but the donor or the senior should be qualified. That we'll check. Okay, so this is just a quick review. Do not create ghost copies. So we discussed this. Whenever you stall, so you need to retain him and the guy behind him. So you need to send zeros to the enable pins of PC and the IFID. And you want the senior to progress. So certainly this is VDD and this is VDD. So that he moves and this guy moves here. The question arises what we are going to do. If we send a 0, we'll be creating a ghost copy of the senior who is here because he progresses and his baggage, we use the word baggage to say his information. So that is retained and that creates a ghost copy. On the other hand, if you make it VDD, then this instruction who is held here also progresses. You are creating a ghost copy of the junior, you are creating a ghost copy of the senior. These are not good. What is correct is I need to connect VDD but drop in the signals which are all zeros for control signals. Thereby we are sending a bubble. In fact, in the 5-stage CPU, it's not necessarily to turn all 9 signals to zeros. Only 4 of them, memory read, memory write, register write, and branch equal, so that we don't branch unnecessarily. So those are the significant ones. Other things like by the way, memory read is important because it has otherwise side effects on the cache. Other things like register destination, etc. are unimportant. Okay, so do we do the same? Yes, we do the same here. We do the same here. For example, we inject the bubble, but bubble injection through a multiplexer is bubble injection in this fashion by sending zeros through a multiplexer is for illustration. All you want is to turn the control signals to 0, which can be done by AND gate, to which you can send a 0. So the simple mechanism is whenever you stall, when stall is true, produce a 0, call it stall B for bar, since we are this stall B is like this, or it is 0 when stall is true, and that 0 makes sure a 0 is sent. So when the instruction goes here, the run is 0, so you injected a bubble. So this is the bubble injection mechanism. This is the actual implementation of bubble injection, whereas this is just for illustration. Okay. Here we are showing stalling. We do not want spurious stalls. How do we avoid? So, one second, I have another. Yes, spurious stalls. So we discussed this. We make sure that the seniors are really register writing so that we do not unnecessarily stall the junior. But we were not checking in the 5-stage CPU of Patterson and Hennessy. We are not checking the junior's intent to read. For all you know, he may be a jump instruction and you may be stalling the jump instruction for no reason. Jump doesn't have any sources. He has no intent to read, but since if we wait for decoding to complete, it takes time. So though we didn't do timing design in Patterson and Hennessy, we can make a justification by saying if we wait until the control unit actually decodes and identifies him as a jump instruction and then use that information, it might elongate the clock. So they allowed a few spurious stalls. This is all just a simple justification. However, that kind of spurious stalls do not occur in lab 7 because um, there's no opcode to decode. On at the ID stage itself, we know whether the run is true or not. So if ID run in means incoming, this side, not outgoing, is true, that means the junior is not a no-op and the senior is not a no-op, and uh, uh, and there is a match of X or Y or both, then we need to stall. Fairly simple logic to stall. Um, what is a wristband flip-flop in the 5-stage pipeline? Do we have in Lab 7 Part 1? The wristband flip-flop has dual purpose. When you switch on power under reset, asynchronously, you clear, 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 clear. This clear causes this bubble, and this clear causes this random instruction to be converted to bubble. This clear converts this random instruction to a bubble, and depositing a 0 means telling the control unit to treat this guy as a bubble and ignore his opcode and produce 9 zeros. So we avoid random instructions in these 4 stages in this fashion under reset. At the same time, the PC is cleared, and if the PC is cleared, the very first instruction is fetched, and that's what is happening. So what is the second purpose? Well, second purpose is if a branch is successful, the branch comes around with the name of IF flush, and that will deposit a 0. So that is the case with the 5-stage pipeline, and the question is, what is the case with Lab 7 Part 1? In Lab 7 Part 1, there is no branch instruction, so it's not dual purpose, single purpose. But that single purpose is also not true, because very much like this, you have this which you can clear. So all this is run, run, run signal. So on the next page, we have this. So this asynchronously makes sure that these are bubbles. And this asynchronously clears so that the very first instruction in the boot up code is fetched. So the run signal, since there's no opcode, and this is the control signals are available right here as part of the instruction itself. Okay, next. Okay, so now we are going to look at one of the exam questions, a 4-element adder. So there are 4 sources, W, X, Y, Z, and all these 4 need to be added. So since addition is associative and commutative, you can add the things in any order. And here where there's no overflow to nullify the instruction, so we are adding a pair, another pair, and the intermediate sums are taken and further added to produce the result. Fairly simple. Okay, so comparison units. How many comparison units? The ID stage RF will be written by the W stage senior. That would be senior 3. So senior 3's write register ID will be compared with the sources of the 4. So there are 4 comparisons here. Apart from this junior being dependent on this senior, which is taken care by internally forwarding register file, we have this junior dependent on senior 1. So that requires 4 comparison units here. And this junior dependent on this senior, does 4 more comparison units. So to answer the questions here, comparison units in the IFRF are 4, comparison units in the comp station is 4 plus 4, 8, and out of which 4 are used. If I'm dependent on my senior 1, I need to get stalled. If I'm dependent on my senior 2, I will get forwarding help. So those are the forwarding multiplexers. That is for forwarding. So that's the answer. And here, instead of doing a tree cascade, 2 adders followed by 1 adder, the same 3 adders, 1, 2, 3, are put in a linear cascade in a 6-stage fashion. And how does it work? Well, again, 4 comparison units between him and me, and he is called senior 4 to me, the junior. We have senior 1, senior 2, senior 3, besides senior 4. So, if my 4 are compared with your destination, your destination, your destination, that makes 12 comparison units, which are besides the 4 comparison units inside. Out of these 12, how many are used for stalling, how many are used for forwarding, and that can be figured out by saying seniors cannot help until they finish, and so only the WB stage guy can help. That means for my W or X, if I'm dependent on my senior 1 or senior 2, I better be stalled. So 2 guys dependent on 2 seniors, 2 times 2, 4 comparison units are used in stalling. Besides that, then that and this. So I, the Y guy, if I'm dependent on my senior 1, I need to be stalled. So that is plus 1. But I, the Z guy, do not need to stall because I can postpone my requirement all the way up to here, by which time all seniors might have gone already, might have helped and gone, or the nearest senior, senior 1, can help me through a forwarding multiplexer. All the so 4, 12, 5, 7. And what are these 7? Actually, I need to draw forwarding multiplexer here because and here. And that solution is shown here. So please do understand, if we do not draw all the forwarding multiplexers, you should be thoughtful to draw the forwarding multiplexers. Sometimes I may draw excessive forwarding multiplexer. For example, if I draw anything here, you should say, no, that is meaningless. I'm going to cross off this. Why? Because W and X were already added. To that further I want to add, how can you help me after processing the data? You are basically, if you help me, you are saying whatever you processed is garbage, throw it away, we start all over. That's not all over. So you don't help somebody by asking him to throw away what he processed. He should have produced meaningful help, result, intermediate result, and if he cannot produce meaningful result, he should have been stalled here. So this kind of forwarding multiplexers, if provided, and if you are asked to cross off, you should know why you should be crossing off. So now you see that I need 7 appropriate comparisons to qualify these 7 forwarding. Which one should help whom, you should be able to figure out by the distance. For example, for only he can help, right? So if he is helping me, so this means I, the junior, I'm helped by my senior 2. But this situation translated to when I was here, my senior 2 was here. So what would you call that? And this is Z. ID Z matches with this guy EX2. And that should have been brought into here and into here to govern this. So that would be EX2, Z matches with the EX2. So please do practice how to write these names. Now, this page is simply asking about this, which is better, the 6 stage or the 5 stage or the 5 stage. Now, in the case of pipeline, normally we ignore the filling time. The very first instruction does take so many clocks. That's called filling the pipe. If we ignore that, then if there are no dependencies and no branch penalties, things keep moving smoothly. So whether it is 5 stage or 6 stage, if the compiler designer could write to avoid dependencies, both of them have the same throughput, clocks per instruction equal to 1. But that is ideal, that's not the case. So we do have stalls. So then you say, how do I compare? If I'm dependent on senior 2, any of us, if we are dependent on senior 2, no problem. That is our plus point, which may or may not be true in the next case. So what is the next case? Next case is, if you guys are dependent on senior 2, you have to stall. So that is the disadvantage. But then I can cite some advantages. If I'm dependent on my senior 1, no problem. Can you do that? If you're dependent on senior 1, can you say no problem? No. So I can think of a sequence of instructions to make him look good by coining instructions where W or X are dependent on senior 2, which doesn't require any stalling, but requires stalling here. If I want you to look good, I will consider a sequence of instructions where the Z, where an instruction, a junior instruction, is dependent on his senior 1 for his Z, and that can be helped directly here, but the immediate senior for Z causes stall here. Okay, I guess we made the point. Okay. Okay, we are going to look at this question. This is a 4-element adder, but one of the 4 is a constant 3. So the question is, do you want instead of W data you want 3, or instead of this, or instead of this? In this design, all are symmetrical. They have the same problem. So it doesn't matter. Either way is fine. But in this design, one of these have greater problems. They need to be stalled if they are dependent on their senior 1 or senior 2. Whereas this guy is only dependent on senior 1. He has difficulty, very much like senior 1, he has difficulty. But Z doesn't have to stall at all. So it makes sense to say, I'm going to replace either W data or X data with the constant, because this guy had the maximum amount of problems. Y is same for both. Z wise, this guy is better. Okay. Next question is this. We added a dummy stage to the 3-element adder, and this is the dummy stage EX0. Otherwise, everything else is same. So how does that work? At the initial look, people may jump to the conclusion that, oh, it is going to increase stalling, increase forwarding. The latter is correct. Yes, there is more forwarding, But increased stalling is not true here. Why? Because uh, when somebody needs, so this guy is more demanding than this guy. So let's talk about him. And by the way, Z can postpone his request all the way until EX2. So you never have to stall like in the before, never need to stall for Z here also. Even for XY, it's the same amount of stalling because if I'm dependent on my senior 1, I need to stall. If I'm dependent on my senior 2, I don't have to stall. And what about you depending on him? Well, he will forward to you. So there's no increase in stalling or reduction in performance. It's a little extra cost of comparisons and forwarding. How many comparison units? Well, you have three sources and compared with one destination of the writer. So three comparison units as before, but I, the junior, um, while you took care of my senior 4 through this, what about my senior 1? What about my senior 2? What about my senior 3? So this three comparisons, three comparisons, and those are those 9 comparison units. Okay, now um, so they are color coded. Only this guy can help, but he is senior 1 to him, senior 2 for you, senior 3 for him, and senior 4 for you. And these two dependent on this causes stalling, others cause forwarding. So fairly simple, though it may look a little complicated. Frankly, there is nothing much, and the stall generated because of these. So you say, I, the junior, I am not an op because ID run in is true. My senior 1, you are not an op because your EX4 run in is not 0. And we have either this or this. So fairly straightforward logic. Under those conditions, I produce stall, which I invert and produce stall B. And that stall B I send to him and him to stall this dependent instruction. And that stall B I send to him to inject a bubble. Okay. So in the original 3-element adder with no dummies, if I, the junior, I'm not an op, if my senior 1 is not an op, and if I have matched with my senior 1 for my X or Y, I would stall. Here the senior 1 is not EX1 guy, but EX0 guy, and the names changed, otherwise it's similar. And forwarding logic, it's always WB right for these cases, and appropriate signal brought to appropriate stage. Okay. Okay. The next question is this, and basically we have a multiplier in EX1, and the second adder in EX2 has a bypass around. That means you can skip to do the second part of the addition. So that gives rise to a variety of instructions and also a possibility that a senior who doesn't do any processing here can start helping his juniors. So not only the WD stage guys, certain type of seniors in EX2 may be able to help. So this is the block diagram, and this indicates so I can either go through this, sorry, or skip this. So the second addition is optional. The first addition or multiplication, there is a bar slash m is required. So A2 means I add here, don't do anything. A3 means I add here, further here. M2 means I multiply here and don't do anything here. I hope I'm telling right. No, instead of multiply to just M or multiply and add. So those are the instructions. So add or multiply in EX1. Within them, I can draw a line like this where I use the EX2 or I skip using EX2. So those are the choices. It's one hot coded. So the signals are named as A2, A3, M, MA. These are one hot coded. So on reset, I clear these one hot coded, making sure that these are bubbles, and on reset I initialize the PC. Okay, that makes sense. Now let's continue. So once again, what are the complexities? There's a multiplier who needs one extra clock in EX1. Since some seniors do not do anything here, they are ready to help. All seniors are ready to help. Seniors who skip, okay, what are the names? A2, A3, M, MA. Oh, then it's clear these two guys do go like this and do not perform additional addition. Such and such seniors here can help you at the beginning of the clock. And there are two people to help you. Certain type of seniors can help you, all seniors can help you, and you should have a pair of forwarding multiplexers closer to the operation to be governed by him, and at another pair to be governed by him. So I hope that makes sense. Then we have what else we have? The Z, as before, does not need any stalling. Okay, so since we have this situation, namely certain type of seniors can't help and certain other seniors can help, so that means this dependency, which looks like this, may cause stall or may not cause stall, may cause stall or may not cause stall depending upon the type of senior. Okay, let's proceed. So again, these are the ones, these are the 5 different types of instructions. We have this control signal called add bar slash m, meaning 0 means add, 1 means multiply, and the skip signal and the solution. No. At this point, let us visit lab 7 part 3, which is not included as a lab, but some ideas can be borrowed, and one of the ideas borrowed from there is skip around. Skip around. In this particular case, since you have only one source from which you subtract 3 or add 4 or do both, if you do both, you subtract 3 and add 4, which is like add 1. So the combinations are do both, that is add 1, do neither, that is simply move. So the source goes round and writes to the destination. And not even write to the destination, then it's a no. only do subtract 3 or only do add 4. So those are the various instructions in lab 7 part 3. And once again, we borrow some ideas. And one of the ideas that we borrow is, if these two are matched, EX1 and EX2 are merged into one state called EX12, then only when add 1 comes, which requires both parts to work, you need one extra clock. Otherwise, if it is subtract 3 or add 4 or a no extra clocks. Okay, that makes sense. Once again, we don't need this WBFF, because first, one of the dual purpose is branch initiated flushing. We don't have branches. And the second is to convert the random signal to a bubble, and that we could take care of, because in the ID stage, I have the data stationary control signals which I can asynchronously turn them into off and proceed. Okay. Here we are again talking about revisiting what is this dual purpose right band flip flop. One is for flushing the junior 3, and one is on reset, on power on, to make sure that there's a bubble here. Okay. While you, dependent on him or possibly him also, need a pair of multiplexers for the closer guy to help, and another pair of multiplexers slightly far off on the left to be used by the less significant senior, who is senior number 2. Okay. So the Z says, I'm not in a hurry. I can get help in EX2. The X and Y say, no, we can't get help in EX2. We need help here. If you are a nice senior who can help me, so please do help me. Otherwise, I would stall for the reason that I am dependent on you. So please understand the difference. So how did this work? A quick review. It was covered separately also, but as a quick review, we can say this. Okay. So if multiply is to be done, that means if it is him or him, I will be doing multiply, and also I'll inform I just came, hence please help me. During this clock, I want to activate a stall, but during the next clock, I want to inactivate it. And many people may think that this is the one they need to use. This is the one they need to use. That is stall M, and stall M through an inverter produces stall memory bar. And whenever you stall somebody in the middle, not ID stage but somewhere here, you have to make sure that you stall the entire pipe, because somebody may be helping me, but if I'm not moving and if these are not stalled, he can move out and we lose that help. So we stall the entire pipe in such cases. So please notice this, that there's a stall dependency bar, stall dependency and stall dependency bar, and stall multiply bar, and they're combined. Whichever stall it is, yes, I and you have to get stalled. So whether it is stall dependency bar or stall multiply bar, if I find a 0 here or a 0 here, I will generate a 0 here. That's negative logic OR gate, which is positive logic AND gate. Okay. And this is saying If stall B is true, I'm going to uh, stall the entire pipe because he can potentially be helping me. And if I do not stall him and him, so they simply walk out, the help will be gone. So, okay, let's proceed. Okay, um, one of the questions was whether the comparison units participating in stall are only these or these. Well, basically, if I'm dependent on him, um, he cannot help me in time. So only these two. But these are also used. Please understand that comparison units participating in producing stall dependency may be disjoint or may not be disjoint from the comparison units helping in forwarding. So why, where, what? Well, if it is a simple design, I need to come back to this. Let's see if I have this. Yeah. In the original Lab 7 Part 1, there are no two types of seniors. Some type of senior requiring stalling, some type of senior who can help in forwarding. If you have them, if you do not have any such overlap, some comparisons will participate in only in stalling, some other comparison units participate in only in forwarding. However, please notice that in this case, for me, senior 1 can provide help, not in all cases, but in those cases where he is anyway bypassing this and is not actually uh, doing some work. So he can help. What type of seniors can help? Well, look at these who do not use this, and as evident from this OR gate, if I'm an A2 or M, I don't need you, and hence I say take this path. And I also say, look, juniors, I can help you. So this pink line says I can help you. Okay. So what are you saying? Depending on the type of senior, senior 1 may be uh, maybe not helpful, hence I may have to stall. And guys who are using this, it's not that they don't want to help, but they cannot help. And guys who use this are A3 and MA. Okay. So about the word disjoint, among the comparison units, some are used for stalling and some are used for forwarding, and these are disjoint. No, they are disjoint in Lab 7 Part 1, but not here. And why? Why? Because the type of senior is MA or A3, they cannot help me, and that goes into stalling. But if the same senior is A2 or M, they can help me. So there is a overlap and they are not disjoint sets. Okay, let's proceed. What is this? We are recollecting multiple multiplexers, multiplexer pairs, FMP, forwarding multiplexer pair, and multiple because there's a senior 1 and there's a senior 2. Senior 1 helps at the end, and senior 1 less significant senior 2 helps first because he is less significant senior and this is more significant senior. Such things we are already familiar with. Stall dependency. If I the recipient, I'm not a no-op, and if you the senior um, such and such guy who says, I'm not done, I can't help you. And if there is a match for X or Y, it is time to call stall D. Okay, stalling the entire pipe. Some students have a little confusion with respect to this. By the way, DCM, data cache miss true, will certainly stall himself when the guy is behind, but he stalls the guy in front of him because he can be helping. So um, he is also held. Okay. So stalling the entire pipe again, I keep missing a point um, here. DCM, if I don't stall, some students will say, in the first clock he helped, why do you need the same thing in the second clock? So they are assuming that this guy is like a human who remembers the value that he was helped. But the fact is, there's only combination logic here, and combination logic doesn't remember. So you need to have him held here so that he can help you in the first clock and again in the second clock. Okay, so that's about stalling the entire pipe. Okay, you may be given a sequence of instructions for you to show your understanding of who requires stalling. We require one extra clock in um, in the EX1, and at that time the entire pipe is stalled. Okay, so MA1, did MA1 reach EX1? Yes, and if he reached EX1, then uh, he should be there for one more clock. Okay, so please notice that something happened. This guy needs uh, a dependency stall, so he is injecting a bubble, and this is the, let me say it again. So MA1 came to EX1 and stayed there, so these two lines are identical. Now M2 says, I want to stall him, so this is causing this stall. So I want to remain here, and thus because of the dependency. Again, M2 guy came and wait there. Then somebody came here and made everybody stall. So you should be able to fill some time space diagram like that. Okay. Okay. Now let's, what happened? Okay. In this slide, we are starting on this question where the original three element adder was added with the additional stage to perform subtract 3, and this is additional operation branch if x plus y is 0. So let's see how it works. Okay, so the point is, and there are bypass paths. So not everybody does subtract 3, not everybody does a final add operation with z. So these are the various operations that are performed Add just xy and forget about the rest, or add xy and subtract 3, or add, can I read? Yeah, xy, xy subtract 3 xyz, and sorry, I need to zoom in. Okay, so now let us list. Add xy and subtract 3, add xyz and subtract 3 also, and branch xy. Okay, so basically um, to this addition, either I can have this or both. So this is both, z is there, s3 is there, this is just this one, and add xyz means not this but this. Okay, I did not write 5 are there, 1 2 3 4 5. Okay, if that is the case, we can understand. Give me 1 second. There are two kinds of seniors. Seniors who are ready to help right from here. Well, if he is AXY, that means he doesn't do this, he can help. If such a senior can help. But other seniors who are doing either this are not able to help from here. Some seniors can help here. AXY can help, and also AXY sub 3, add XY subtract 3 can help from here. Everybody of course can help from here. Z, like in the previous cases, does not require stalling because it can postpone receiving help as late as EX3. But for others who need help here, there are more occasions to get stalled because of dependency. And since subtract 3 and adding Z is over and above this necessary operation, so you don't forward once you come into this or this. Oh, how come you can forward here? Let's see. That is xy subtract 3. Yeah. Are there excess multiplexers? Yes, I think that's an excess multiplexer because this is already something processed. So let me cheat and look at the solution to make sure that I am. What do I need to do? I need full screen. Okay. Okay. By the way, this guy has a delay slot. Oh, we have the names here. So if he has a delay slot, don't flush the junior one. Meaning from junior one side, don't inject a bubble. Let him come as is because he is supposed to survive with a delay slot. Yes, this should not be there because you do not help when somebody has already processed. You cannot say throw away that and I will help you. That makes sense. By the way, in this, for a variety, I have requested students to put the forwarding units in their respective stages, HDU in the respective stage. So this will cost you more comparison units because they are redundant replications. So that's the purpose of this exercise. So how many comparisons I need? Because at times you cannot get help from this guy like this, at times you cannot get help from this guy like this. So you we two juniors having problem with senior 1, senior 2, 4 comparisons are needed in HDU. Okay, how do you count these 7? Well, I have these 3 pairs of multiplexers because certain types of seniors can help me, certain types of seniors can help me, and everybody can help me. And so 3 plus 3 plus 1, 7. Okay. Now, how many comparison units here? So I need a comparison unit to forward to him, and I need a comparison unit to forward to him, and this should be removed. This is the branch, and if it's a branch and this is the equality 0 checker. Is x plus y equal to 0? If so, if you are a branch and x plus y is 0, BR1 branch is successful, and that will cause the 16-bit value which is brought here and taken across. So let's trace the line. You, the multiplexer, you are getting branch target address from here, and the decision to branch is also coming from here. So you need to make sure that they are coming from the same stage. Okay, so I, the branch, if I'm successful, I would not anyway, you will survive. So there's no question of bubble injection. Whether I'm successful or not, you will survive. You will naturally survive if I'm not successful. But even if I'm successful, since one delay slot is required, you will survive. So there's no need for bubble injecting and gates here. And not here, because there's nobody, you are not stalling somebody to inject bubbles to the next stage. Okay, next, what else I have? What is this? If stall dependency is true, I will stall and inject bubble. But you guys do not have a right to stall if I say you guys get out. The successful branch, can override. So you can stall only if it's not a case of defying the authority of a successful branch. I'm talking like in a court martial case. You and this senior is telling this junior who is trying to stall, hey, you defy my authority, I will court martial you. Only if I say it's not a case of successful branch, then you can cause stalling and injecting bubble. So that's the meaning of this. Same thing, if BR1 is not true, then you are allowed to do what you would normally do. So that's the logic there. Since we have the forwarding unit and HDU spread out like this, you need whatever comparison units, whatever control source register addresses you need to bring. And in such cases, I simply bring, it's difficult for students to draw so many lines. So if you look at the exam question, IDXA, EX1XA, EX2XA, EX3XA, WBXA, I simply brought all signals all the way and asked students to cross off what is not necessary. So this comes out to be something like this. Let us make sure that we understand. So please notice that all are required here, but some are not required here. How come and what is the basis? The basis is as follows, namely x and y are processed here. So he should take care of and he should take care of. So bringing x address, y address beyond that does not make sense. So I crossed off. So again, you should be able to cross off things like this, etc. We already talked about one second. Okay. What is this? The branch target address is not calculated and is part of the instruction and came here, and I utilize the branch target address at appropriate point of time to deposit into the PC. So that being the case, do not carry that anymore through the pipe. So that's the meaning of that. Yeah, this again we are reiterating that if somebody has already produced some result, you shouldn't say throw away that result and I'm going to forward to you. That's never the case. Whoever is involved in producing the result might have needed your help and you might have helped him, and that's good, but not this. Okay. Next. So we talked about this. So instead of so many comparison units, namely 13, you can manage with 9 if you open these boxes and remove redundancies. For example, there are 3 sources, so 3 internally forwarding comparison units are necessary. Apart from that, I, the junior, could be dependent on senior 1, senior 2, senior 3. Okay, so I need 3 plus 3 plus 3. That would be 9 comparison units. So are you saying 3 plus 9? Perhaps yes. Yes, 3 plus 9. Okay, now